Welcome to another lesson of calculus. In this lesson, we will continue talking about parametric differentiation. In taking the derivative, the first derivative dy over dx is found by taking dy dt divided by dx dt. And the second derivative, d squared y over dx squared, is d dt of dy dx divided by dx dt. Now let's look at some examples. First one, if x is equal to t cubed minus 1 and y is equal to t squared plus t, find d squared y dx squared. In other words, find the second derivative. So let's look at our given information. X is equal to t cubed minus 1. The first derivative, we're going to be calculating the dx dt and the dy dt, and then dividing the dy dt by the dx dt. Now for x equal to t cubed minus 1, dx dt is equal to 3t squared. And for y is equal to t squared plus t, dy dt is equal to 2t plus 1. Now dy dx is going to be equal to dy dt over dx dt. That's going to be your dy dt, which is 2t plus 1, over your dx dt, which is 3t squared. Now to the second derivative. D squared y over dx squared is equal to d dt of dy dx over dx dt. Now d dt of dy dx is equal to, using the chain rule, 3t squared times 2 plus 2t plus 1 times 6t. So it's low d high minus high d low over low squared, or the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the denominator squared. So that's over 3t squared squared. You're going to expand the numerator and simplify, so it becomes 6t squared minus 12t squared minus 6t all over 3t squared squared. That's going to be negative 6t squared minus 6t all over 3t squared squared. You factor out a negative 6t from the numerator. You have negative 6t, brackets, t plus 1, close brackets, all over 9t to the fourth power. Then simplifying the top and the bottom, dividing by 3, the 6 and the 9, divided by the t and the t to the fourth power, becomes negative 2, bracket t plus 1 over 3t to the third power. So that is your d dt of dy dx. Now we're going to take this and then divide it by your dx dt. So that's going to be negative 2t plus 1 all over 3t cubed, then divided by 3t squared, which was dx dt. So d squared y dx squared is now going to be equal to negative 2 bracket t plus 1 over 9t to the fifth power. So that is your second derivative of those parametric equations. Next example. If x is equal to 2 sine theta and y is equal to 1 minus 4 cos theta, find d squared y dx squared. Solution. Given that x is equal to 2 sine theta, dx d theta is equal to 2 cos theta. given y is equal to 1 minus 4 cos theta, dy d theta is equal to 4 sine theta. Now dy dx will be equal to dy d theta over dx d theta. That's going to be equal to your 4 sine theta over 2 cos theta. And so dividing by 2, we have 2 sine theta over 2 cos theta. And sine theta over cos theta is tan theta. So your answer is 2 tan theta. That's your first derivative. Dy over dx will be equal to 2 tan theta. Then I want to go to our second derivative. So we take d theta of dy dx for the top part, and that's going to be 2 secant squared theta, because the derivative of tan theta is secant squared theta. Then the second derivative, d squared y over dx squared, is going to be this d theta of dy dx divided by dx d theta, and dx d theta was 2 cos theta, so it's going to be 2 sec squared theta divided by 2 cos theta. The 2's will undo each other, so you're going to be left with sec squared theta over cos theta, which you can write as sec squared theta times 1 over cos theta, but we know that 1 over cos theta is sec theta, so then it's going to be sec squared theta times secant theta. And so your d squared y dx squared will be equal to secant cube, this is sec cube theta. All right, so let's look at another example. This time we're just finding a tangent line to the parametric curve. So we only need to find the first derivative here and then plug in these points. So find a tangent lines to the parametric curve. X is equal to t to the 5th minus 4t cubed, and y is equal to t squared at 0, 4. So then let's take the first derivatives. We are given that x is equal to 2 to the 5th minus 4t cubed. So dx dt will be equal to 5t to the 4th power minus 12t squared. And we're given y is equal to t squared. So dy dt will be equal to 2t. dy dx then is going to be dy dt divided by dx dt, which is going to be 2t divided by 5t to the 4th power minus 12t squared. I want to plug 0, 4 now into the original equation to get from values for t. So we plug in x equals 0, because these are x values. You need values of t to plug back into your derivative equation. So when x equals 0, t to the 5th minus 4t cubed equals 0. So if we factor t cubed from t to the 5th minus 4t cubed, you're going to have t cubed bracket t squared minus 4, set that equal to 0. So we know then if t cubed equals 0, then t is going to be equal to 0. And if t squared minus 4 equals 0, then t squared is equal to 4, so t will be equal to plus or minus 2. We're going to plug y equals 4 into the original equations. So when we let y equals 4, we'll have t squared equals 4, 4 equals t squared. So t squared equals 4, so t will be the same plus or minus 2 again. So there are three values of t that we have can plug into our derivative equation. T equals 0. When we plug t equals 0, our derivative function was 2t over 5t to the fourth minus 12t squared. So we plug in 0, that's 2 times 0, over 5 times 0 to the fourth minus 12 times 0 squared. So that's going to be a 0 over 0. So that first derivative is undefined at 0. So let's try t equals 2. And t equals 2, dy dx is going to be equal to 2 times 2 at the top over 5 times 2 to the fourth minus 12 times 2 squared. So it's going to be equal to 4 over 80 minus 48, which is equal to 4 over 32. It's equal to 1/8. So the derivative at 2 is 1/8 of the gradient. At t equals 2, that's going to be 1/8. Now let's try t equals negative 2. dy dx here is going to be equal to 2 times negative 2 over 5 times negative 2 to the fourth power minus 12 times negative 2 to the second power. That's going to be equal to negative 4 at the top over 18 minus 48. So that simplifies to negative 4 over 32 and simplifies to negative 1 over 8. Let's use the 1 over 8 here and the negative 1 over 8 as gradients for our equations. So then for the gradient of 1/8, you put 1/8 into the equation. Y is equal to mx plus c, where y was equal to 4 and x is equal to 0. So 4 is equal to 1/8 times 0 plus c, so c will be equal to 4. So thus our equation there of the tangent line will be y equals 1 over 8x plus 4. For the equation where your gradient was negative 1 over 8, we have 4 is equal to negative 1 over 8 times 0 plus c. So c will be equal to still 4 right here. So your equation here will be y is equal to negative 1 over 8x plus 4. Thank you for watching. Thank you. All right? Good.